Today we're going to talk about solving systems using any method, so just by choosing a method. And so in order to do that, sometimes we need to be able to rearrange an equation. So we're going to practice rearranging the following equation into slope-intercept form. We'll notice that this is y equals mx plus b. So since it's y equals, essentially all we have to do is isolate or solve for y. So if we have 16x minus 4y equals 20, our job is to isolate or to get that y all by itself on one side of our equation. So to do that, I'm going to move this 16 out of the way. So I'll end up subtracting 16x from both sides. Well, I haven't changed my negative 4y at all, so I'll just bring that down. I'm going to have negative 16x plus 20. I can't combine those because they're not like terms. Well, now I've got negative 4 times y, so I need to rearrange that, so I can do that by dividing everything by negative 4. Well, this is gone, so we end up with y is equal to, well, negative 16 divided by negative 4 is 4x. Positive 20 divided by negative 4 is negative 5. Slope-intercept form is y equals 4x minus 5. Okay, so sometimes when we are solving systems of equations, we need to be able to rearrange our equations. So remember, you do that just by using your inverse operations, right? Your inverse operations to move things around. So today we're talking about 4.1e, solving systems all three ways. So this first one we want to solve by elimination. So remember, to solve by elimination, we need our equations to be lined up. So here our x's are lined up, our y's are lined up, our equals signs are lined up, and our whole numbers are lined up. So it looks like everything is lined up, so that means it's set up for elimination. So we can just start. Also notice, looking at this, that we already have a pair of opposites. Negative y and positive y are already opposite, so we don't need to multiply by anything. We can just combine these. Well, x plus 2x is 3x. Negative y plus y is going to eliminate to 0. And 2 plus 1 is 3. So we end up with 3x is equal to 3. Well, we can divide by 3 on both sides. So we end up with x is equal to 1. Well, if we know x is equal to 1, we still have to find y. So we can pick either of these equations to plug it into. So I'm going to say 2 times 1 plus y equals 1. Well, 2 times 1 is just 2 plus y equals 1. I'm going to subtract 2 from both sides, and that tells me that y is equal to negative 1. So we have the x value of 1, the y value of negative 1, so our solution is 1, negative 1. Now let's look at another way. So solve by substitution. We have the same equations, x minus y equals 2, and 2x plus y equals 1. But we want to solve by substitution. So remember, to solve by substitution, we either need to know what y equals or what x equals. So I'm going to rearrange this top equation. I'm going to rearrange it to figure out what x equals. So we have x minus y equals 2. But if I want to rearrange it so I have x by itself, all I need to do is add y. So we know that x equals y plus 2. So we're going to look at the equations. X equals y plus 2, and 2x plus y equals 1. And we are going to use our substitution. So we're going to take what x equals, and we're going to plug it in for x. Okay, we're going to take what x equals, and we're going to plug it in for x. So instead of 2 times x, we'll have 2 times y plus 2. Okay, and then this part of our equation will stay the same. We're still going to add y. It's still going to be equal to 1. Right? Notice the only thing we change is that instead of that x we're multiplying by y and by 2. Well, first step, we need to distribute, so we'll have 2 times y is 2y, 2 times 2 is positive 4, and then we're still adding y, and it's still equal to 1. And from here, we can just combine like terms. 2y plus y is 3y, plus 4 equals 1. We could subtract 4 from both sides, so we get 3y. 1 minus 4 is negative 3. 3y equals negative 3. We could divide by 3 on both sides to figure out that y is equal to negative 1. Well, if we know what y is equal to, all we have to do is plug that into one of our original equations. So we could use either of these equations, or we could use our rearranged equation. It doesn't matter. They're all equivalent. So any equation we plug it into will end up with the same answer. So let's go ahead and plug it into x minus y equals 2. Well, if x minus y equals 2, then we have x minus a negative 1 equals 2. Well, that just means x plus 1 is 2. Subtract 1 from both sides. X is equal to 1. And again, you could plug it into either of the other two equations to confirm that answer. So our solution would be 1, negative 1. Then, solve by graphing. Well, to solve by graphing, we need our equations to be in slope-intercept form. Okay, neither of these is in slope-intercept form, so we actually need to rearrange both of them. Well, for this x minus y equals 2, we can subtract x from both sides, so that would be negative y equals negative x plus 2, and then we need to divide everything by negative 1. So when we isolate y, we get that y is equal to x minus 2. And then we'll do the same thing for that other equation. 2x plus y equals 1. Well, we can just subtract 2x. So we find that y is equal to negative 2x plus 1. So the system we're going to graph is this equation and this equation. Okay, the system we're going to graph is y equals x minus 2 and y equals negative 2x plus 1. So let's go ahead and graph those. Well, for that first equation, we have a y-intercept of negative 2 and a slope of 1. So we're going to go up 1 over 1, up 1 over 1, up 1 over 1 for all of our points. I'm going to fill in the back half of my line for accuracy. Remember, to go backwards, you just do the opposite. So I'd go down 1, back 1 to fill in the back half of the line. Here's our line. For y equals negative 2x plus 1, well, our y-intercept is a positive 1, and our slope is a negative 2. So we're going to go down 2 and over 1, down 2 and over 1. And again, I'm going to fill in my line. I'd go up 2 and back 1 to fill in the back half of my line. And we have our intersection point. So looking at our intersection point, that looks like it's the point 1, negative 1. Okay. So what did you notice about all three of your solutions? Looking at 1, negative 1, 1, negative 1, and 1, negative 1. Hopefully you noticed that we solved the same system using all three ways, and all three solutions were identical, right? All three solutions were the same. Which method of solving do you prefer? So this is kind of personal preference, but it's also kind of talking about that choosing the best method. So for example, for this particular problem, I prefer elimination because the original problem was set up for elimination, so I didn't have to do the extra step of rearranging my equation. So for this problem, I preferred elimination. And I preferred elimination because it was set up for elimination. Because it was set up for elimination. Okay. Now there's a little bit of personal preference. If you don't like elimination, you could always rearrange your equation to use substitution or graphing if those are one of your preferred methods. But you can also base your preferred method or your method of choice off of what the system is set up for.